All right, here we're going to talk about paramagnetism and diamagnetism. It's a really easy concept. Let me show you what's going on. Paramagnetism is a word we use to describe atoms or molecules that have unpaired electrons. And diamagnetic is the word we use when there are no unpaired electrons. For atoms, this is really easy. For something like nickel, which is in shorthand, argon with an extra 4s2 3d8. You know what the electron configuration of this looks like. We have our argon, then we have our 4s2, and our 3d8. 1, 2, 3, 4, 5, 6, 7, 8. And the fact that these electrons are unpaired makes nickel paramagnetic. Nickel 2-, i.e. a nickel with 2 electrons added to it, would not be paramagnetic. It would be diamagnetic, because then these 2 electrons would be paired up and you wouldn't have any unpaired electrons left. I could show you another example here. We've got zinc. Zinc is argon 4s2 3d10. So you've got your argon inner shells, 4s2, and then your 3d has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of these electrons are paired up, so a zinc atom is diamagnetic. Now, that's really easy for atoms because you're familiar with these electron configurations. But when it comes to molecules, it gets tougher. You need to use something called molecular orbital theory. For oxygen, the molecular orbitals that come out when you have 2 O's attached to each other are sigma 2s antibonding, sigma 2p, pi 2p, pi 2p antibonding, and sigma 2p antibonding in that order from lowest energy to highest energy. I've included the inner shells here. I've put a little dashed line. Some teachers don't bother showing the valence shell, but I'm going to. Oxygen brings 6 valence electrons total, and it brings 2 inner electrons. If you take a look here, you've got 1s2, 2s2, 2p4. It's 8 electrons total per oxygen. That means I need to fill 16 electrons if I'm going to do the whole molecular orbital diagram. So, 1, 2, 3, 4. Notice I'm following the Aufbau principle of going from the bottom up. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I'm also following that rule. Actually, maybe that was Hund's rule. Whatever. I'm also splitting them up before. Oh yeah, Hund's rule is spread them out before you double them up. Anyways, long story short, 16 electrons for the O2 molecule. The molecular orbital electron configuration diagram looks like this. What you'll notice is that we have 2 unpaired electrons, which makes O2 a paramagnetic molecule. Now, if you were going to do the Lewis structure for O2, you probably wouldn't see unpaired electrons. But because of the molecular orbital theory, it is a paramagnetic molecule. Bonus question for you. O2 2-. That's the same molecule but with 2 extra electrons. Well, 1 extra, 2 extra, and all of a sudden, because there are no unpaired electrons, I'm now diamagnetic. That's how this kind of stuff can change depending on the charge, all right? So, all you have to do is memorize that paramagnetic means unpaired electrons are there. Diamagnetic means there are no unpaired electrons. Don't forget your electron configuration diagrams for atoms. And if you're that far into chemistry, don't forget your molecular orbital diagrams for some of the molecules like N2, F2, etc., etc. And remember, they aren't all exactly like this. Hey, best of luck to you. Para and diamagnetic yourself all weekend.